Hi, my name is Ashwini Miskin. My topic for literature survey is indoor localization techniques. So these are the topics covered in the literature survey and we'll go through them one by one. So what is indoor localization? Indoor localization is a method which is used to determine or estimate the location of a user or a device in an indoor environment. Indoor location systems have made it easier to locate people or objects. In outdoor environment, the Global Positioning Systems (GPS) can provide good location estimates. However, the GPS solution cannot be used in the indoor environments. In this kind of environment, which is typically called GPS-denied environment, the GPS signal is very poor because of the lack of line of sight between the satellites and the receiver. Due to the large number of applications that can benefit from a location service in indoor environments, indoor location systems have been an important topic in recent years. So there are more than 100 companies who are working on this indoor tracking and navigation technologies and systems. So there are many applications of indoor localization. 1. Detection of the location of products in the warehouse. Monitoring patients, staff, and equipment in the hospitals to improve navigation. Help customers locate stores or products in the shopping malls. Detecting the location to find the parked car in the parking garage, and many more. So these are the different techniques that are commonly used for indoor localization. So let's go through each of these techniques one by one. Receive signal strength indicator is one of the most commonly used technique for indoor localization. It is based on measuring the power present in a signal sent from an access point to a client device or vice versa. It can be assumed that as the number of available access points increases, a greater amount of information can be collected. Hence, the accuracy could be increased if relevant information is obtained. This, however, also works as a trade-off. An increase in the number of access points would increase the interference between different signals. RSSI techniques are among the most cheapest and easiest methods to implement, but they do not provide the best accuracy. Filtering is necessary to improve system accuracy using RSSI-based localization. Fingerprinting is one of the known techniques used for indoor localization, and this technique uses radio signals to learn the user or device location, and it works by collecting the signal values, the fingerprints, during an offline phase, measured at different calibration points throughout the area of interest, and recorded in a database, which are then compared with the online measurements from the database when the system is deployed to estimate the user location. During the online point, a group of access points has some specific location that vary from a set of access points stored in a radio map, as some access points may be replaced and new access points may be added. Online positioning therefore requires a selection process for the access points. A range of algorithms are present to match offline calculations with online calculations. It is important to know that fingerprinting techniques could provide accurate localization estimates. However, they are very sensitive to environmental changes over time. In trilateration technique, it measures the object's location by measuring the distance from 3 points of reference based on the triangle's geometric properties. Thus, it is also called as range measurement technique. In trilateration, the tri says that at least 3 fixed points are necessary to determine a position. Depending on 3 non-collinear distance measurements, the target object's 2D location is calculated. The location of the target objects is determined by the intersection of imaginary circles for 2D. Time of flight or time of arrival technique is used to measure the distance between the transmitter and the receiver by using the signal propagation time. Basic geometry can be used to calculate the location of the device with respect to the access points. It is possible to find the distance between the reference node and the device by multiplying the light speed with the TOF value. Time of flight requires strict coordination between the transmitter and the receiver, which adds up to the system cost. It has been recognized that with the aid of the ultra-wideband technology, the time of flight technique could best support fine time resolution. Frequency domain resolution techniques are widely used to achieve high resolution time of flight from the channel frequency response. Time difference of arrival technique takes advantage of the difference in signal transmission times measured at the receiver from different transmitters. This is different from the time of flight technique where the absolute signal propagation time is used. In contrast, Relative time measurements are used in place of absolute time measurements at each receiving node. The transmitter must be on a hyperboloid with a constant difference in the range between the two units of measurement for each time difference of arrival measurement. Time difference of arrival technique does not require receiver synchronization. However, only the transmitters needs to be synchronized. Triangulation. Triangulation technique is used in conjunction with the geometric concept of angles of the triangle to determine the receiver's position. Rather than measuring distances between nodes like trilateration, triangulation-based positioning is based on angle measurement, although they work similarly. The position of the target node can be determined by intersecting several pairs of angle direction lines with triangulation. This approach requires only two beacons to estimate the location in a two-dimensional plane. Three or more beacons are usually used for location estimation to enhance the accuracy. It requires highly directive antennas or antenna arrays to find the direction. Angle of arrival technique uses antenna arrays at the receiver end to calculate the angle by which the transmitted signal affects the receiver by employing and calculating the time difference in the arrival of individual antenna array elements. Angle of arrival's main advantage is that the device or the user position can be measured in a 2D environment with as few as 2 measuring units or 3 measuring units in a 3D environment, and that no synchronization of time is required between the measuring units. However, the drawbacks include that it relatively needs more complex hardware requirements and there will be location estimate deterioration as the mobile target moves from the units of measurement. Channel state information is a received signal strength enhancement. Although the received signal strength only offers aggregate signal strength data, the channel state information analyzes the strength of the signal and the phase shift of the individual signal elements. Because of this, distinguishing directly received signal from the reflections is easier. The channel state information includes data on the channel between the sender and the receiver and the individual level data subcarriers of each pair of transmitting and receiving antennas, and records the amplitude and the phase of each subcarrier. The technique of dead reckoning is to identify the current position based on last calculated position and the motion information. So here, two techniques can be used to estimate a person's distance traveled. One is pedometer-based dead reckoning and the other is pedestrian dead reckoning. So in the pedometer-based dead reckoning approach, it works by estimating the steps and then counting these steps by using the stride line information to measure the distance traveled. In the pedestrian dead reckoning technique, it calculates the distance traveled directly. That is, the initial measurement unit is attached to a person foot and it calculates the acceleration and angular velocity changes. The data obtained is then analyzed, transformed into referential motions, and the movement's distance and the orientation are measured. So this is how the dead reckoning technique works. So in scene analysis technique, the scene analyst refers to the type of algorithms that first collect features that are the fingerprints of a scene and then estimate the location of an object by matching online measurements with the closest prior location fingerprints. RSS-based location fingerprinting is commonly used in scene analysis. So now that we have seen the different techniques which are used for indoor localization, let's have a look at some of the technologies which are used for indoor localizations. I have mentioned a few technologies here, which is Wi-Fi, Bluetooth, ultra-wideband, and ultrasound. Let's have a look of them one by one each. The Wi-Fi technology is principally accustomed to provide internet connectivity capabilities to various devices in personal, public, and industrial environments. Most of the newest laptops, smartphones, and other mobile user devices are Wi-Fi enabled, making Wi-Fi the best suitable for indoor localization and one of the most examined localization technologies in the literature. Next is the Bluetooth technology. Bluetooth exists within the 2.4 GHz ISM band and comprises of the specification of physical and MAC layers to connect various fixed or moving wireless devices within a particular personal space. Bluetooth Low Energy (BLE), commonly defined as Bluetooth Smart, which is the latest version of Bluetooth, delivers an increased data rate of 24 Mbps and more energy efficiency with coverage range of 70 to 100 meters. So one of the advantages of using the Bluetooth technology in the indoor localization is that it is small and easy to assimilate smartphone, PCs, etc. So next is the ultra-wideband technology. In the ultra-wideband technology, it works in the microwave band, the low frequencies of which are capable of penetrating building materials like walls. The technology is in the main use for short-range communication systems like laptops, peripherals, and alternative indoor applications. Ultra-wideband has been a very enticing technology for indoor localization as a result of its resistance to interference from different signals. Next is the ultrasound technology. The ultrasound-based indoor location systems are referred to as fine-grained systems with centimeter-level location accuracy. Ultrasound position systems depend on the time of flight calculation of the ultrasound signal, measuring using sound velocity. Ultrasound networks which have been built are either narrowband or wideband. Ultrasound position systems deliver a range of benefits like low device cost, accuracy, reliability, scalability, and high power performance. So now that we have seen the different techniques and technologies that are used in the indoor localization, let's discuss some problems and challenges that are encountered when implementing indoor localization systems and algorithms. The first one is accuracy. Accuracy is a significant user prerequisite for positioning systems. Different systems can have different accuracies. However, the accuracy is still a very challenging area of interest for many researchers in the field. Next is cost. Cost is yet another challenge. Localization systems that require additional infrastructure, where larger companies might be able to purchase them, whereas smaller organizations are limited in lieu of these costs. Hence, some of the infrastructure equipment and bandwidth can therefore be avoided by using the existing infrastructure. Next is energy efficiency. The energy efficiency of the localization system is very critical for the widespread acceptance. Most current localizer systems use greater energy to deliver higher precision. In today's localization systems, it is quite difficult to achieve high precision without draining the battery of the device, and this can lead to user dissatisfaction. Hence, therefore, there is a need to improve the energy consumption of the localization systems. Next is scalability. So one of the most important requirements is that the system must be scalable. That is, it must be capable of simultaneously find or provide facilities to large number of users in large area. Low scalability can lead to poor system performance. Hence, because of all of these challenges, there's a lot of room for improvement in this field. Hence, we conclude that from the entire survey, we got to learn the various techniques, technologies, and challenges in the field of indoor localization, and how the developments in the location-based technologies have led to a huge increase in the market in the localization-based services. We also saw how the various wireless technologies and techniques are combined to improve the performance of the indoor locations. However, in the future, we still expect that the accuracy should be improved with more research alongside improve the internet operation of various wireless localization systems so as to extend the positioning scope. Thank you.